Hello everyone, welcome to Skilled Dev. Trey here, and in this lesson, we're going to implement a linked list data structure. Or more specifically, we're going to write functions that operate using a linked list head node. This is because in interviews, it's much more common to be given the head node of a linked list, and then you need to iterate and operate from there. This is in contrast to our other data structure implementation lessons where we use an object. But here we're really going to focus in on what's important for interviews. So we're going to have 4 functions. All of them will use this linked list head. We'll have a prepend function that will add a node before our current head, and that will become the new head. We'll write an append function that will add an item to the tail, or add it to the end of the linked list. We'll have an insert function that will insert a linked list node at a given index. And finally, we'll have a delete function that will remove a node from the linked list. Let's quickly run through the fundamentals of a linked list and understand these key concepts that will be used in each of our functions. Our linked list is represented by nodes, where each node in the list points to the next item. The first item is the head, and finally the last item is the tail, and this node points to null. For the functions we're writing, or how we'll commonly see linked lists in interviews, we start with a head, so we will only be given this head node. Then to iterate through the linked list, I typically initialize a current node, which is going to be set equal to the head node. Then to iterate, we'll move forward while our current node is not equal to null, so while there's a next node in the list. Then to move to the next spot, we set our current node's value to current node.next, or the item after the current item. So the item after the first spot is this next item, so current node is now equal to next. And now we're at the second item in the list. Then we continue to iterate just by updating this current node value each time and moving it to the next item. Finally, we reach the end of the list when the current node is equal to null. To prepend to a linked list is very simple. You already have access to the head node, so when you pass in this new item, you simply set its next value to the previous head and then return it as the new head. To append an item, we must iterate to the end of the list. So we start with the head and iterate until we reach the tail. Once we see this null value, we set the previous tail's next value to this new item. Then we set its next pointer to null. This is going to take O of n linear time because we have to iterate through all n nodes. It's worth quickly noting that if you had access to the tail or a tail pointer, you could append in constant time. This is similar to how we prepended the head, we just need to update one node. Deleting an item in a linked list is an interesting case because we don't actually delete the item, we just move past it in the list. So let's see what we mean in this visual. When you find the item you want to delete, you simply set the next pointer of the item before it to the item after it. So now there's just no nodes in the list that reference it. For example below, we have this node 10, and we want to delete the node 11. Well, to delete 11, we set the next pointer of node 10 to node next.next, so the item after its next pointer. And what this does is just removes that reference to the node here, to that node 11. Now, there's no longer any other node in the list that references it, and it's not being used at all in our program. Now our programming language will realize this and simply garbage collect it and remove it from memory. To insert an item, we iterate forward that number of spots, then we set its next pointer to the one that should be after it, and we update the next pointer of the one before it to point to this new node. So all of our functions are really based around similar concepts. You're given this head node, and then you need to iterate into the list a certain number of spots. Once you land on this spot, you just update next pointers to complete the action. This is the same for append, prepend, insert, and even delete. And now we're ready to implement our linked list functions. Our linked list is going to be comprised of standard nodes. We'll have a data attribute and a next pointer that always points to the next item in the list. We'll have our 4 functions, prepend, append, delete, and insert. And we can see that each of them takes a head node as one of the parameters. Each function will also have additional parameters depending on the action that it needs to perform. Alright, so let's start with prepend. We can see that it takes a data parameter, and this is just going to be the data that we want to store in the new node that we're pre-pending. So the first thing we'll do is create this new linked list node. And we'll call it pre-pended node. Since we want this item to be the new head, or the first item in the list, we need to set its next pointer to the previous head. So now the previous head is the second item and the pre-pended node is the new head. Then to signify we have a new head, we simply return pre-pended node. For the append function, we're going to be adding an item to the end of the list. It also takes a data parameter, which is just the data of the node we're adding. So let's initialize our new node. The difference here is that we're going to need to iterate all the way to the end of the list. We're going to need to find that tail node and then add this new node after it. So we'll initialize a current node to the head, and this will allow us to walk through the linked list one node at a time. We don't know the length of the linked list, so we just need to iterate until we reach the tail. And we know we've reached the tail when we find the node who has a next pointer that references null. As we said, to iterate, we just set the current node to the current node's next value. Then once we find the tail, all we need to do is add this new node after it. So current node.next, and we add appended node. So now appended node is the new tail. We didn't change our head, so we simply returned the head we started with to give reference to the start of this linked list. And now we're ready to implement the delete function. We delete items by index. So we'll pass the number of spots into the list that we want to delete a node. First, we need to check if we want to delete the head node. This would be an index of 0. This means we don't iterate into the list at all. So if index equals 0, and then to delete the head, what we do is return the head's next value. So the second item in the list is now going to become the head. There will no longer be any variables in the code pointing to it, so now that previous head will just be removed from memory and garbage collected. If our item is deeper into the list or past the head, we then iterate to the node that precedes it. When we get to this preceding node, we set the preceding node's next pointer to the item after the one we want to delete. This will remove the reference to the node and delete it from our linked list. So we'll initialize preceding node to the head. Then we'll start to iterate. And here we'll use a for loop because we do know the number of items we want to iterate through. So start at 0, and then iterate to index -1. So this puts us one spot before the item we want to delete. Then preceding node, we'll just keep iterating forward to each next item. Then the node we want to remove is the one after the next value. So preceding node.next is equal to node to be removed.next. This would be equivalent to saying preceding node.next.next. All we're trying to do is get preceding node to reference the item after the one we want to be removed. Then, since no items in our list or in the code are pointing to the one that we want to delete, it will be removed and garbage collected and taken out of memory. Then we just return the head to give reference to the start of our linked list. And finally, we'll implement the insert function. This function also takes an index where we want to insert this node, and then the value or the data that we want that node to contain. The first thing we need to check is an edge case where index is 0, and that means we want to insert a new head, which is equivalent to a prepend. So we say if index is 0, this is simply a prepend, so we do prepend head and pass it the data. If we want to insert a node past the head, then we need to iterate to that spot based on the index. So we'll initialize our inserted node, And when we iterate forward, we want to land on the preceding node again, and then we set this node's next value to the item we're inserting. So we use preceding node to iterate. We use our for loop, since we know the number of spots, to go into the linked list. And we land one spot before the index. We move our preceding node to the next value each time. And then, once we land there, we can perform the insert. But we also need to maintain reference to the node after inserted. Because we're adding this new node, its next value must continue the list. So we take the preceding node's next pointer and store it in this variable. So preceding node.next is equal to the inserted node. So now our new node is in the list. We also need to add inserted node's next value to this node after inserted. Now we continue the full chain of our linked list from beginning to end. And finally, we return the head and have completed our insert function. Now let's just run some quick examples to ensure it works. We start ahead with the value 42. We append 3 nodes to that. We should have 4 items here. Then we prepend the value 9,000. We delete the node at 2. Then finally, we insert 2 nodes. So it's just like we said. We have these 4 nodes. We add 9,000 at the beginning. Then we delete the item at 2, which was 100. And then finally, we insert 2 additional nodes. And that's our linked list implementation. Thanks, everyone, and I'll see you in the next lesson.